Australian researchers are hoping to revive deep-sea marine life in Victoria's Apollo Bay by creating novel sea sponge nurseries. Marine biologists have just deployed 120 tonnes of rubble to the bay's seafloor in the hopes it will flourish and attract further marine life. For more, I'm joined now by Dr. Chris Gillies, a marine biologist with Offshore Biotechnologies, who was just in Apollo Bay for the project. Chris, good morning. Thanks so much for your time. Firstly, can
Good
I
morning.
just get you to explain to us what exactly a sea sponge is?
That's right. So a sea sponge is an animal. Many people believe it might be a plant, but it's one of the most common animals that we have in the ocean. It goes largely unnoticed, but they occur from the shallow waters right down to the deep canyons, from coral reefs down to the Antarctic. And they essentially, in the deeper waters, provide the primary habitat for all of the fish and marine life to live.
Okay, so you were just in Apollo Bay. Can you talk us through the project and what you were doing there?
That's right. So we're part of a really exciting project. It's really a bit of a world first where we're developing new methods to restore and enhance these deep water sponge communities. We were working about 12 miles offshore in the Apollo Marine Park, and we were deploying a number of different types of substrates or reef materials to attract marine life. We put about a 25-meter swimming pool's worth of limestone rubble in different sites within that marine park. And we also deployed 64 concrete mats that had a very special chemistry associated with the concrete to attract marine life. And the last component that we undertook was to collect sponges from outside the marine park, cultivate those sponges, and then redeploy them back into the ocean, just like you would on land to collect seed and replant a forest. And that really is a world first. No one has ever collected 100 different species from the bottom of the ocean before in such depths, cultivated them, and then re-put them back to try and reseed these sponge garden communities.
Yeah, can you take us through a little bit that sort of initial phase of collecting the sea sponges and recultivating them before putting them back into the ocean? How does that all work, and how different of a method is this from what has been done previously?
Yeah, so we used a small scientific dredge to collect the sponges from the seafloor, and we were able to sort them out on the vessel. I said we're 12 miles offshore and sort of 4 to 5 meters of swell. It's not necessarily where everyone wants to be, but as a marine biologist, we love it out there. We then brought them back to the hatchery in Seagen Aquaculture on Phillip Island, where Seagen were able to develop a specialist facility there, a cold water facility to keep these sponges alive, and then develop methods to feed them and then cultivate them quite rapidly. And I think that's the novel component. It's a little bit like coral reef restoration, where they're able to fragment corals. We were able to fragment these sponges, and we could have a single sponge have 50 or 60 babies, if you like, from that one sponge. And we seeded them on these little reefs, these little concrete reefs that we've made, and then redeploy them back on. So to be able to undertake that journey from 12 miles offshore, down in the depths, back into the shallows, into a facility, and then back down to complete that full cycle is really something very novel. And it gives us lots of hope to be able to manage these deep water environments for both climate change and also developments in the future.
Yeah, pretty incredible. And some of the pictures that we've been looking at as well are pretty spectacular. You've said that you believe that these sort of sponge nurseries could be used to revitalise fisheries, repair damage to the seafloor. What sort of damage are we seeing here, and how could this work potentially?
Yeah, so it's really hard for people to visualize, and of course, if you're not a scuba diver, understand what happens on the bottom of the ocean. But we have two really big stresses there. We, of course, have climate change, and we see coral bleaching pretty easily, but we don't see the effects of climate change on our seabed communities. Sponge gardens can bleach, but also the acidification of the ocean changes the nature of the marine life as well. And that would be like, stripping out trees from a forest. So that's one major impact. And in particular, the Australian government, Parks Australia, are really interested in developing these new hands-on methods to manage these deep water ecosystems. The second stressor is around development. Most people might be aware of some oil and gas extraction in these waters. That's a fairly small footprint in the grand scheme of how big the ocean is. But much of that material will be removed out of the ocean, so we need to find ways to remediate the seabed. And of course, we have new industries starting to develop, whether that's offshore wind farms or offshore aquaculture, that will also have impacts. But the beauty of the ocean is that we have a great opportunity to develop a coexistence between nature and this infrastructure, and that's exactly what we're trying to develop with these new methods, is to have much more nature-friendly infrastructure and projects out there in the ocean.
How long until you can sort of tell whether or not this has worked in the way that you'd like it to? And do you think there is the possibility of then expanding this sort of project to elsewhere in Australia and across the world?
Yeah, absolutely. So one of the lucky things we have as being marine biologists is things happen pretty quickly in the ocean. So if you're restoring a forest, it might take you 20, 30, 40 years to have a mature forest. It typically doesn't take that long in the ocean. So within sort of 5 to 10 years, we should expect to see many of these sponge species growing, certainly along the right trajectory to work out whether we have success. In the short term, we'll know within the space of a couple of months whether the sponges that we deployed on the seafloor are surviving and starting to thrive. And absolutely, these methods are methods that we're now beginning to commercialise to be able to work with the offshore energy sector and also work with the Australian government, Parks Australia, to manage, 1/3 of Australia's marine estate is managed by Parks Australia. It's a huge area and a massive undertaking to make sure that these ocean ecosystems are healthy. And by these methods will also help park managers, just like on land, have new ways to manage, pests and climate change, and do that in a practical way where we can physically see the changes happening before our eyes.